Today we're going to be talking about section 8.2, the law of sines. The law of sines allows us to work with not just right triangles. So today what we're going to start talking about is working with triangles that are oblique triangles. Now, that brings to mind the issue of what is an oblique triangle. The definition of an oblique triangle is just a triangle that does not contain a right angle. That means your triangle could have three acute angles, as in a triangle that would look something like that. All three angles are less than 90 degrees. Or you could have a triangle with an obtuse angle. Something like that, where this angle up here is greater than 90 degrees. It doesn't matter which one we're talking about. The only rule of thumb here is that an oblique triangle does not have a right angle. So we're going to start with the definition of what it means to solve an oblique triangle. This is similar to when we said solving a right triangle. To solve an oblique triangle means to find the missing lengths of its sides and the measurements of its angles. That means, again, we are just going to be looking for everything that is missing in the picture that was originally provided to us in the problem statement. Now, if we think back to geometry, there were certain classifications of triangles that we used to prove triangles similar or the same. We are going to be using those same rules here. So we have four special cases of triangles. I'm going to start listing them out because I find it easier for you guys to recognize them that way. Case one is angle side angle, or ASA triangles, or SAA triangles. You will notice in both of these two cases, they state two angles and one side. It just is how the triangles are arranged. So case one is the case when you have one side and two angles. Case two are triangles like SSA. This time we have two sides and one angle given by the problem statement. So we'll say case two is two sides and the angle opposite. Are known. Now, this case two is a special type of case of triangle. This is something that we call the ambiguous case. The ambiguous case means there's extra work that's going to be required when we go to actually solve these types of triangles. Case three is the case of triangle where we have SAS, side angle side. This is the case where we have two sides and the included angle. And case four is the case of side, 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 or the case where we have three sides that are known. Now, I know triangles, going back that far to your geometry brain, is sometimes difficult, so I'm going to go ahead and draw you the triangles. So an angle side angle triangle is something where you know maybe this angle, and you would know the side in between them. Those would be the three pieces of information you are given. Side angle angle means you know some side and then the next angle and the angle following it. Side side angle is the type of triangle where you know one side, you know the following side, and you know the angle after the following side. Side angle side, you know side, the angle, and then the next side. And side, side, side is the one where you know all three sides of your triangle. Now, these triangles are split up into 4 cases. 2 cases correspond to the need to use law of sines. And the next 2 cases actually mean you need to use law of cosines. Both of these 2 laws allow you to solve an oblique triangle. However, each one allows you to use different information that could have been given to you in a problem statement. Today, we are solely going to work on cases that are either case 1 or case 2. And then in section 8.3, we will move on to work on case 3 and case 4 using law of cosines. Before we get into the actual use of what law of sines is and solving questions, I want to go back and talk about this case 2, where case 2 was the SSA triangle, where you know 2 sides and the angle opposite. Now, I want to bring up the fact that this is the type of triangle back in geometry that we said it really told us absolutely nothing about a triangle. Both of these 2 triangles drawn down here are SSA. I know a side, I know a side, I know an angle. That one is very clearly SSA. This triangle over here, I know an angle, I know a side, I know a side. That makes this ASS. It doesn't matter which way these are written, it's still 2 sides and 1 angle. So these 2 are both SSA triangles. Now, when I go to teach SSA triangles and the fact that these are actually called the ambiguous case, the ambiguous case means it's kind of vague. You don't know what's happening. Now, because it's kind of vague and we don't really know what's happening, we have to do a little bit of extra work in order to finish solving these types of questions. The reason I bring this up is because the questions that make you do extra work really do kind of behave like an ass. Therefore, I like to teach this version of the name of these triangles. If you have a triangle and you know an angle and the following 2 sides, angle, side, side, you should know you have to do extra work. So, what is the law of sines? The law of sines for triangles with sides A, B, and C and opposite angles, capital A, capital B, capital C, respectively, is sine of A over side length A equals sine of angle B over side length B is also equivalent to sine of angle C over side length C. What this is saying is the ratio of the sine of your angle divided by that side length is equivalent between all 3 sides of your triangle. Now, you only need to use 2 pieces of this at a time. It doesn't matter which 2 pieces. And what we're going to be doing is we're going to be setting up proportions. Just for reference, as a reminder, when you go to draw a triangle, side length A, B, and C, angle A is the one opposite A, angle B is the one opposite B, and angle C is the one opposite C. The only difference between an angle and a side length is angles are capitalized, side lengths are lowercase. Okay, so moving on, we have example 1. Example 1 says solve the triangle A equals 40 degrees, B equals 60 degrees, and side length A is 4. The first thing we should do with all these questions is draw ourselves a triangle. So I'm going to draw myself a triangle. And I'm going to label it A, B, C. From here, all we're going to do is we're going to put the information we know onto our triangle. So we know angle A is 40 degrees. So that means this angle down here is 40 degrees. Angle B is 60 degrees. So the angle up here is 60 degrees. And we're told that side A is 4. Side A is the side across from angle A, so we know that side length is 4. The next thing I want us to do is actually identify what type of information we are given. Well, we are given angle, angle, side, so that means this is an AAS or an SAA. It doesn't matter which way you name it. Now, what that does for us is we can identify whether this is case 1, case 2, case 3, or case 4. I'm going to remind you right now, we are in the Law of Sines chapter. We are working with only case 1 and case 2 right now. That means we are working with a case 1 triangle. The only time you will ever be working with a case 2 triangle with Law of Sines is if it's an ASS. So from here, I need to use my Law of Sines. Law of Sines states sine A over A equals sine B over B equals sine C over C. And we just need to figure out which pieces of this we actually want to use. Now, I notice here I need to solve the triangle, which means I need to find angle C, side C, and side B. It doesn't really matter where we start. However, let's start with the easiest piece of information we know, and that is the fact that all the angles in a triangle add up to 180. Therefore, to find angle C, all I need to do is take 180 degrees, subtract my 60 and my 40 from it, because those are the two angles I have on the inside. And I'm told that angle C is 80 degrees. Again, make sure you are boxing your answer with the letter it is actually the answer to. Otherwise, it's a big jumbled mess and hard to follow. From here, I have 2 side lengths left that I need to solve for. I need to solve for side length C and side length B. It doesn't matter which one we start with. We just need to choose one of the 2. What I'm going to choose to do is I'm going to choose to use my proportion that I know everything about and set it equal to whichever one of the 2 proportions I want to solve for next. So I'm going to use B first. I know that sine of angle A, which is 40 degrees, over side length A, which is 4, is equivalent to sine of angle B, which is 60 degrees, over side length B. From here, it's just solving a proportion. I'm going to cross multiply. B sine of 40 equals 4 sine of 60. From here, I need to solve for B. So B is equivalent to 4 sine 60 over sine 40. From there, you will have to use a calculator. You can use scientific or graphing. Make sure it's in degrees. 4 sine 60 divided by sine 40 gives me B equals 5.39. I have 2 sides now, A and B. I have 1 side left to solve for. Do not fall into the trick of using Pythagorean theorem. This is not a right triangle, and Pythagorean theorem only holds true on right triangles. So we are going to have to go and use Law of Sines to solve our last side still. Law of Sines tells me sine, and I would use the one you were given information for. So sine of A over A. So what that tells me is sine of 40 over 4 equals sine of C, which C is 80, over side length C. From there, what I'm able to do is I'm able to cross multiply again. It's the same solving process. C sine 40 equals 4 sine 80. Divide by sine 40 on both sides. So C equals 4 sine 80 over sine 40. So angle C is, and I will just plug that in, 4 sine 80 divided by sine 40, and I get out 6.13. Notice I do wait till the last step. I'm not decimal approximating those. I'm plugging one entire thing into my calculator. Example 2, solve triangle A equals 35 degrees, B equals 15 degrees, and C equals 5. So, first thing we do every time is we label our triangle. So I'm going to draw a triangle ABC. I already have one drawn on the paper for us. So triangle ABC, Angle A I know is 35 degrees, angle B is 15 degrees, and side length C has a value of 5. So that gives me this kind of information. Looking at that, that is an angle side angle, ASA. This also falls under case 1 of our triangle cases. What I'm going to do from here is I'm going to use whatever information I can to solve for the easiest thing first. The easiest thing for me to notice is I have 2 angles, I have 1 missing. I know all three angles in a triangle add up to 180 degrees. So in order to find angle C, I just need to subtract the other 2 angles from 180 degrees. So C is going to be equivalent to 180 degrees minus 35 minus 15. Subtracting those values, we get a value of C is 130 degrees. Now, I have all 3 of my angles, which means I am going to be able to solve for my 2 missing side lengths. In order to solve for my 2 missing side lengths, I need to go back and use law of sines. They give me a ratio of a sine value of an angle compared with its side length. So we are going to start off and use the idea that sine of 15 degrees over B, because I don't know what side length B is equivalent to, I do know this angle now, sine of 130 degrees over 5. Notice that I will always choose to use the part of the triangle that I have both the angle and side length for. I need both pieces in order to set up a proportion that I can solve. From here, you do the same process, cross multiply. So B sine of 130 degrees equals 5 sine of 15 degrees. Divide by sine 130, so B is equivalent to 5 sine 15 degrees divided by sine of 130 degrees. And we will just plug that into our calculators. So 5 sine 15 divided by sine 130, and I get at a value of 1.69. So that tells me B is 1.69. From there, I still have 1 side length left to solve for. Again, you cannot use Pythagorean theorem because this is not a right triangle, so we have to use law of sines again. In order to use law of sines again, I know that sine of 130 degrees over 5 is equivalent to sine of 35 degrees over A. From here, we will cross multiply, so A sine of 130 degrees equals 5 sine of 35 degrees. Divide by sine of 130, so A equals 5 sine of 35 degrees over sine of 130 degrees. Plug it into our calculator, 5 sine 35 divided by sine 130, and that gives me a value of 3.74. Example 3. Solve the triangle A equals 3, B equals 2, and A equals 40 degrees. First things first, we're going to set up a triangle. A, B, C. Now, what do I know? I know side length A is 3, so 3. Side length B is 2. And angle A is 40 degrees. From here, remember the first thing we always do is we identify what type of triangle it is. So I have angle, side, side information. Angle, side, side. Well, those are the annoying triangles. So that means this is a case 2. Or what we labeled on that other page is something called the ambiguous case. The reason we call this an ambiguous case is because you have three options when you are given this type of information. Option 1, the information you were given could not form a triangle at all, meaning this last side length is too short to connect to that first side length, and you have a giant gap in your triangle, thus not forming a triangle. So you can have no triangle. You could be given information that gives you an option of one triangle and one triangle only. Or you could be given information that could actually work for two different triangles. A triangle here on the inside and the triangle here on the outside. It's kind of like that one leg is being swung in and out. Now, the reason behind that is because we are actually only given information on this angle here, this side length, and this side length. There are certain times that this side length here and the side length there could be the same length, and therefore this side length's changing. So you could have two triangles. You can also get out one triangle, which is a case like that. You have to actually test to see which of these you get out. I will tell you now, if you get out no triangle, it is clear from the very beginning that you get out no triangle. However, one triangle and two triangle, you have to check the same amount of work to figure out which one of those two it is. So let's get started. We are given an angle and two sides. On the last couple examples, we started by finding the last angle that was missing. We are not able to do that here because we actually have two angles that are missing. Therefore, I'm going to start by finding angle B. It's the only other one I can get to with the information that we started with. I know I can set up the proportion sine of 40 degrees over 3. That much information was given to us. The question is, what else could I use? The only other number I'm given is that 2. And that 2 allows me to solve for what sine of b over 2 is. So this gives me a value for angle B. I'm going to multiply by 2 on both sides or cross multiply. So 2 sine 40 degrees equals 3 sine B. I need to get sine B by itself. I'm going to divide by that 3 again. 2 sine 40 degrees divided by 3 equals sine of B. And then how do I get that B out of my sine function? There's only one way we know how, and it's to take the inverse of both sides. Before we take the inverse of both sides though, I first want to figure out what this decimal approximation is. So we're just going to plug that into our calculator. 2 sine 40 divided by 3. That gives me approximately 0.4285 equals sine B. Now, the reason we go ahead and do that is at this point you are actually able to figure out whether this no triangle option is what your answer is. And the answer in this case is it definitely has at least one triangle that is formed, because we know sine of B, that value it produces, has to be between -1 and 1. So from here, I'm going to now take the inverse of both sides, sine inverse of 0.4285 equals B. Second sine inverse, 0.4285. And that tells me B is 25.37 degrees. Now, I got out an angle value for B. That means I definitely at least have one triangle. My answer is not no triangles. Now the question is, could I be creating one triangle with the values given, or are there actually two different triangles that could be created? So this is what we need to figure out now. The way we are going to figure this out is we are going to look at how many angles actually have a value of that when you take the sine. So I want to know how many angles produce a sine value of 0.4285. The way we do that is we are going to go over to our unit circle. We know 0, pi. So now what I need to know is I need to know where my angle is if I get out a positive sine value. So we're going to use all students take calculus. I know it's positive in my first quadrant and my second quadrant. Now, we do actually know the angle in the first quadrant. We know this angle was opened up 25.37 degrees. The question is, could there have been actually a second angle that was opened up? Because it has to stay between 0 and pi though, because I know that my angles in a triangle only add up to 180 degrees, and 180 degrees is pi. So from here, what I really want to figure out is I want to go off and I want to know what this angle over here would be. And I'm going to label that angle B2. If B1 is 25.37, angle B2, if this other angle were to exist, would be 180, all the way to pi, minus that 25.37 degrees. Now, 180 minus 25.37 gives me a value of 154.63. The question we have at hand is, could that actually be another angle that was formed by B? In order to check that, we're going to go up and we're going to add angle B2 to that angle A that we were given. So I want to know what this 154.63 plus 40 degrees would be. That gives me 194.63 degrees. Do I even have enough degrees left in my triangle to come up with an angle C? No. So I don't have a second triangle. I have one triangle and one triangle only. So from there, I have an angle B, have an angle A. I need to find angle C. Angle C, I'm still going to keep it labeled C1 just so I stay consistent, is going to be 180 degrees minus 25.37 degrees minus the 40 degrees I was already told. And that tells me my angle C is 180 minus 25.37 minus 40 is 114.63 degrees. I now have my two angles. I just have this one side length left to find. The way we're going to go ahead and find that is going back and using the law of sines. Sine of 40 degrees over 3 equals sine of your C, 114.63 degrees, over side C. Cross multiplying, C sine 40 equals 3 sine 114.63. Divide by sine 40 on both sides, 3 sine 114.63 degrees over sine 40 degrees. Plug that into your calculator. And you get out a value of C equals 4.24. And that is side length C1. Now, if you were to have two triangles, that doesn't mean it creates both triangles at the same time. What that means is it could create one of the two triangles. So it either has an option between two. It creates one triangle and one triangle only, or it can't create a triangle at all. And that's what you're really checking for in this ambiguous case. Example 4. solve the triangle A equals 6, B equals 8, and A equals 35 degrees. So first things first, we need to draw our triangle. So angle A, angle B, angle C. I have a 35-degree angle. Given by angle A is 35 degrees. I have a side length B of 8 and a side length A of 6. So what information am I given? I have angle, side, side. I have an ASS triangle, case 2, which unfortunately means we have that annoying extra pesky work. So, first things first, we need to start somewhere. I need to find another angle. The other angle I'm going to have to find in this case is B, because it's the only other piece of information I have. So we are going to start with sine of 35, the piece I know everything about, over 6. Now I'm going to set that equal to sine of B over 8. We're going to cross multiply. 8 sine 35 equals 6 sine B. You can divide by 6, so 8 sine 35 degrees divided by 6 equals sine B. At this point, we're going to find our decimal. Let's just make sure there's a triangle that actually exists. So 8 sine 35 divided by 6. That gives me a value of 0.7648 equals sine B. That number falls between -1 and 1, therefore I'm guaranteed to have a triangle. So from there, I'm going to take the inverse of both sides. Sine inverse of 0.7648 equals B. And that gives me angle B is 49.89. Now, from here, I'm going to label this B1 because I don't know how many triangles this information is creating, but I know it could be creating more than one. I know there are 2 possibilities for this triangle. So, what I'm going to do from here, I'm going to take this number and try to figure out where it could have occurred on my unit circle. So, where does it occur between 0 and pi? It is a positive sign value again, so that means it's either in quadrant 1 or it is in quadrant 2. The quadrant 1 angle, we actually already know. We know this angle here is 49.89. That will always be the B1 angle your calculator gives out. The question we have at hand is, what is this B2 angle, or what could it be? Well, I know B2 is just going to be whatever 180 degrees, because we went all the way to pi, but we were short of it, minus 49.89 degrees is. That gives me a value. B2 is equivalent to 130.11 degrees. Now the thing we have to check is there a possibility for an angle C? So in other words, what is A plus B2 equivalent to? Well, that would be 130.11 degrees plus 35 degrees. That gives me a value of 165.11 degrees, which is less than 180. Therefore, I do have a C2 that is a possibility. C2 would just be whatever 180 minus the 2 previous angles were, so minus 165.11. So I know C2 could be
14.89 degrees.
In other words, there are two possibilities of triangles that could have been produced by the information given. We could have this big pink triangle, or we could have a different triangle. It's not producing both at the same time, it's producing one or the other, but they are both options. From here, you actually have to finish finding all the information for both triangles though. So that's why I separated them by color so you can clearly see there's two different triangles. So I'm gonna finish off the purple triangle real fast. So first off, we are only missing one piece of information on this purple triangle, and that would be the side C. We find side C by using sine of 35 over 6 equals sine of
14.89 degrees over C. Then we solve the same way we have been solving, so we get 6 sine of 14.89 degrees equals C sine of 35 degrees. Then dividing by sine of 35 on both sides, we end up with 6 sine of 14.89 degrees divided by sine of 35 equals C, giving us a C value of 2.69.
So that tells me that side there would have been 10.42 on that triangle. Or it would have created the triangle that has these, and again, I'm still missing that side length of C. Side length of C can be found by taking sine or we have to go finish finding the other triangle it could have created. Notice we've now found B, A, side B, and side A. I'm missing all the information on C. So we're going to start by finding angle C1. Angle C1 is going to be 180 degrees minus the 35 that was given in the question minus the 49.89 degrees. So plugging that into your calculator, 180 minus 35, you get out a value of 95.11 degrees. So C1 was 95.11. From there, we need to find side C1. So that gives us sine of 35 degrees over 6 equals sine of 49. Equals sine of 95.11 degrees over C. So C sine 35 degrees equals 6 sine 95.11 degrees. Divide by sine of 35, 6 sine 95.11 degrees divided by sine of 35. Plug it into your calculator, sine 95. And you get out the value of C side C1 would be 10.41. Example 5. Solve the triangle A equals 2, C equals 1, and C equals 50 degrees. So we need to start by drawing ourselves a triangle. So triangle A, B, C. Side A is 2, side C is 1, and angle C is 50 degrees. So again, what kind of information do I have? I have angle side side, so angle side side. That's an ASS triangle. That makes it one of those pesky little case 2 triangles, which means we have to do a little bit of extra work. So to start off, the piece of information I have to start off finding is angle A. So sine of 50 degrees over 1 equals sine of A over 2. I'm gonna cross multiply, so 2 sine 50 degrees equals sine A. What is 2 sine of 50? That gives me 1.53 equals sine of A. Now, at this point, there should probably be an alarm bell going off in your head about the fact that we cannot get out a sine value greater than 1. Therefore, angle A doesn't exist. Therefore, we can't actually have a triangle. However, if you don't believe me, plug in sine inverse of 1.53 to your calculator. When you do that, your calculator either says undefined, domain error, or error, something along those lines. It is not an issue with your calculator. It just does not work because that is outside the bounds of -1 to 1. Therefore, your answer is no triangle. And there's no more work required. Now, yes, some ASS triangles require you to do double the amount of work. Some require you to do a third the work. It just depends on the question. There is no way to easily tell you actually have to go through and do the work every time. Example 6. To measure the height of a mountain, a surveyor takes 2 sightings of the peak at a distance of 900 meters apart on a direct line to the mountain. The first observation results in an angle of elevation of 47 degrees, and the second results in an angle of elevation of 35 degrees. If the transit is 2 meters high, what is the height h of the mountain? Now, first things first, we are going to start by drawing ourselves a picture of what's happening. So, let's draw ourselves a mountain. I have a mountain over here. Anytime you're looking at an image of a mountain, know that the peak comes down to the center. The peak down to the center forms a right angle with the earth. This is just assumed to be true because you can always draw a straight line from an item up in the air straight down to the earth at a 90-degree angle. Now, from there, what we are able to do is I know I have a person who's using a little sighting camera and looking at the peak of the mountain. And this thing has an angle of elevation of 47 degrees. And then I know the person picks up his camera and moves back. Now, he's still looking up at the peak of that mountain, this time with an angle of elevation of 35 degrees. Now you will notice that the height of these sightings is not actually straight with the earth, even with the earth. It is actually, and it says 2 meters high. So I know this distance here is 2 meters. And I know he picked up and moved back 900 meters. So this gives me an image of my mountain and what is actually occurring. Okay, now let's simplify that picture. So what I currently have is I have a mountain peak coming straight down to the earth, forming a 90-degree angle with the earth. And I have 2 sightings being taken. So I'm gonna simplify my picture into 2 triangles that look roughly like that, where my person taking the sightings is here and there. Copying down the image, I know that this height here is 2 meters. I know this distance here is 900 meters. This angle is 35 degrees, and this angle here is 47 degrees. Now, what this question is asking us for is it's asking us to find the height of the mountain. So the distance from here to here. And I'm gonna label that my height. The easiest way for us to find that height is to look at this smaller triangle over here. This is the only triangle I currently have any information about. So I'm gonna start by finding out information about this triangle. The first and only piece of information I can find right now is this angle right here, which I'm gonna go ahead and label capital C. This angle here combined with this 47 degrees combines to give me 180 degrees or a straight line. So I know that angle C should be equal to 180 degrees minus 47 degrees. That gives me an angle C of 133 degrees. From there, I'm now able to figure out what this angle up here is. I'm going to go ahead and label that A. So if I want to figure out what that angle is, I know all my angles in a triangle add up to 180 degrees. And I know one angle in my triangle is 35 degrees. And the other angle in my triangle is C, or 133 degrees. So I know angle A is equivalent to whatever 180 minus 35 minus 133 is. Well, that gives me a value of 12 degrees. So now I know all three angles in my triangle. I know one side length. So I'm going to solve for what this side length is over here. Solving for little c, I know I can use sine of A, or sine of 12 degrees, over 900 equals sine of 133 over side length c. Cross multiply, we get c sine 12 equals 900 sine of 133. And divide by sine on both sides gives me c equals 900 sine of 133 over sine 12. Plugging that into your calculator, you will get a value for this side length here. That side length gives me a value of 3,165.86. So I now know all the pieces of information on that smaller triangle by using law of sines. The reason I chose to find the sides I found is because now I am looking at one large right triangle where I know my inside angle, I know its hypotenuse, and I'm looking for its opposite side. Opposite and hypotenuse are related using sine. So I know that sine of 35 degrees is going to be equal to whatever the opposite is, or h, divided by my hypotenuse, which is 3,165.86. To solve for h, I'm going to multiply by that 3,165.86 on both sides, giving me 3,165.86. Sine of 35 degrees gives me h, and so h works out to be 3,165.86 times sine of 35, 1,815.86 meters. Now, if you look at the last sentence that was given to you in this problem statement, if the transit is 2 meters high, what is the height h of the mountain? Now, yes, I solved for the height of the mountain, but the ground is still 2 meters down below that. So the actual height of the mountain is going to be that plus the 2 meters of the transit, giving me a total height of 1,817.86 meters. Example 7. Coast Guard Station Zulu is located 120 miles due west of Station X-Ray. A ship at sea sends an SOS call that is received by each station. The call to Station Zulu indicates that the bearing of the ship from Zulu is north 40 degrees east, or 40 degrees east of north. The call to Station X-Ray indicates that the bearing of the ship from X-Ray is north 30 degrees west, or 30 degrees west of north. We need to find out two things. First, we need to find out how far is each station from the ship. And secondly, if a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? Again, every time I attack a word problem in trig, I draw myself a picture. So, I have two Coast Guard stations. And then I have a ship out at sea. So it says Coast Guard Station Zulu is located 120 miles due west. The one that's due west is Zulu, so that makes this station Zulu. And that makes this station X-ray. And we know how far apart they are. They are 120 miles apart because we are told that Zulu is 120 miles due west of Station X-ray. Now, from here, what we're gonna do is we need to account for these bearing measurements. So I'm gonna draw one coordinate axis for Zulu, because Zulu has a bearing from it, and one compass or coordinate axis from X-ray, because X-ray has bearing measured from it. I am told that the call from Zulu indicates that it is north 40 degrees east. So it went north and then east. Well, that makes sense because that is an angle in the northeasterly direction. And we know that this angle here would be our 40-degree angle. And then the call to Station X-ray says north 30 degrees west. Northwest, okay? So that makes that angle 30 degrees. What shape did this form for us? It just so happened to form a triangle. So we need to figure out how far is each station from the ship. There are a few things that might be a little weird. The fact that we have no angles inside of our triangle and we only have one length. So, where do we start? We know that this angle here, the full angle, is 90 degrees. Therefore, am I able to figure out what this portion of my angle is? Well, it would just be whatever 90 minus 40 is, so that makes it 50 degrees. Same thing's true over here. This forms a 90-degree angle. Well, 90 minus 30, that tells me this angle here is 60 degrees. Now, that gives us angle side angle information, or case 1. Therefore, I'm able to use law of sines to figure out my lengths. So, first off, I'm gonna label them Z, X, and Y. We need to figure out what angle Y is. So angle Y is going to be 180 minus 50 minus 60, or 70 degrees. So now I just have all the information that's inside of my triangle. So I just need to figure out what the distance is from each. So a distance Z and distance X, just based on the way that triangles are labeled. This is going to be misleading when it comes to actually working out the problem and solving things. However, going off of what we know about triangles, the angle name is the side opposite it. So let's first find the distance between Z and Y, or this distance X. I know that's going to be equivalent to sine of 70 degrees divided by 120. And that's going to equal sine of 60 degrees over my distance X. Now, distance X is actually the distance to Zulu, so I'm gonna go ahead and label that Zulu. Cross multiply, X sine 70 equals 120 sine 60. So X is equal to 120 sine 60 over sine 70. And so X is equal to, plugging into your calculator, you get out 97.82 miles. Now we have to do the same thing. We need to figure out its distance from X-ray. So I'm going to label this X-ray. And to find its distance to x-ray, I'm really looking for this length of z. So sine of 70 degrees over 120 equals sine of 50 degrees over z. So z sine 70 equals 120 sine 50. So z equals 120 sine 50 over sine of 70. So the distance to x-ray, or the length of z, plugging into your calculator, gives you a value of 110.59 miles. So now we know how far each ship is from the station. That's our answer to question 1. Part 2. If a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? This 200 miles per hour, that is our rate. That's how fast the helicopter can fly. I also know how far the helicopter has to fly. Because it says to the nearest station, that means we're trying to make it to station Zulu. So therefore, part 2. We know a distance, we know a rate, we want to know how long. The only formula I know is distance equals rate times time. The distance he has to fly is 97.82 miles. He flies at a rate of 200 miles per hour. And we just want to know for how long. Well, how do I solve for t? Divide by 200 on both sides. 97.82 divided by 200 equals t. That tells me t equals 0.49 hours. .49 hours is approximately 29 minutes. So it'll take 29 minutes for the helicopter to reach the closest ship.